Alright, there are 6 more problems on here, and I'm going to try to show you 2 ways to do slope all the time, graphically, and then algebraically using this formula. And this formula you need to become very familiar with, right? Slope is change in y, y2 minus y1, change in x2 minus x1. And I'll show you that 3 times in each way. So, slope can also be rise, this is rise, over run, this is run. This guy right here goes up 1, 2, 3, 4. So my rise over run, we know our rise is 4. It goes over 1, 2, 3, 4. So my run is 4 for a slope of 1. So graphically you can see rise and run. But you can also choose to use this formula. Alright? So this says let 3, 4 be x1, y1, so we'll call this x1, y1, and it says let 3, 8 be x2, y2. So here we go. y2 minus y1 is our rise, 8 minus 4 is our rise, x2 minus x1 is our run, 3 minus 3 is our run, and we get 4 over 0, right? Which we know, right, is, I'm not going to do it over here. Right? Slope is undefined, and the line is vertical. It's something you need to understand. Vertical lines are undefined. Alright, next ones. Again, there's 2 ways to do it. I'm going to show you both. Alright, so this right here is my rise down to here. Rise. This right here is my run from here to here. So my rise goes from 9 down to negative 5. Right? From 9 to negative 5, going down is negative 14, and my run is from negative 1 to 2 this way. So that's 3. Down 14 over 3, positive 3. For a slope of literally negative 14 thirds. That is my slope, negative 14 thirds. Done. With this table, we're going to do this a little different, right? X and Y. We'll call this x1, y1 here. We'll call this x2, y2 here. I'm going to write them. 4, 5 will be x2, y2. 3, 5 will be x1, y1. And my slope is, we'll write the formula, y2 minus y1 over x2 minus x1, and it is 5 minus 5 over 4 minus 3, which gives me 0 over 1, which is a 0 slope. Alright. 2 more to go. Alright. So, I'm right here. The height of a plant y in centimeters after x days is the linear relationship and these points. Boom, boom. So here we go. Looks like they put the 15 on the second spot, so we'll call this x1, y1, x2, y2, y2, 25 minus 15, y1, x2 is 40, minus 30, y2, which gives me 10 over 10, which is a slope of 1. Alright, so let's see what our x's are. X's are days, y's are centimeters, probably in growth. Alright, so the slope being 1 means that every day the plant grows 1 centimeter. There it is. I think there's one more here. Or not. Yeah, there's one more. Well, let's get these guys right here. I'll show you 2 ways again. I can do rise like this. And I can do run right here. From 10 to 25, my rise goes up 15. From 50 to 77, it goes over 27. So my slope is rise of 15 over run of 27. Now in this situation, they can both be reduced by 3, which gives me 5/9. Alright? And interpret. That means, let's see, every 9 degrees Fahrenheit equals 5 degrees Celsius. That's what that means. Alright, last one. These are our points. So we'll call this x1, y1, x2, y2, and our slope is y2, y1, x2, x1. 4,000 minus 3,000 over 60 minus 40, that's my x, which gives me 1,000 over 60 minus 40 is 20, which gives me 100 over 2, or 50 over 1. Let's write it as our fraction. 50 cubic feet every 1 hour is what that means. How can you relate the rate of change in the slope in a linear relationship? They equal rise over run. How's the slope formula related to the definition of slope? y2 minus y1 equals rise. x2 minus x1 equals run. How can you interpret real world situation? Apply the meaning to numbers. All right. We'll pause that.